Hello, my name is Zack Nicklin, and I'm currently the UAS Program Manager for Northland Community and Technical College. I am also the UAS Director for the newly funded National Science Foundation Center of Excellence, the National Center for Autonomous Technologies. Um, so I'm also an Army veteran. I enlisted back in 2003 as a 33 Whiskey, an intelligence and electronic warfare systems maintainer and integrator. Great job, taught me lots about computers and electronics. And right afterwards, I got tapped to go and start working the Shadow program, the RQ-7 Bravo. Back at this time, the Shadow UAS had about a 14-foot wingspan, about a 12-hour flight time, and it was wholly an intelligence asset, not yet an aviation asset. So that's why they pulled intelligence and electronic warfare maintainers over for the electronics, and then they actually had generator mechanics serving as the power plant mechanics, so working on the engines. So when people think drones and UAS, unmanned aircraft systems, what they tend to think is little quadcopters, things like your DJI Phantoms or Inspires, maybe even the enterprise stuff such as the M210s, and then of course there's other brands out there that are making some decent products, but I think with about 80% of the market share, DJI equipment is what most people are out there using. Working small UAS is all well and good. In fact, I've got about 8 years experience with small UAS. Well before the Part 107 process started, we were working, with COAs and 333 exemptions. Got a couple hundred hours working different DJI and Centera equipment, along with some Lockheed Martin stuff, and it's been great. It's been an eye opener, and we have a lot of fun doing it, and we can pull a lot of really good information. But to me, at least, the job market with small UAS is really centered around a couple of different types of people. The first is the entrepreneur. Somebody who's willing to go out there and take some risks and build up a business from scratch. That's not necessarily something that we're all cut out to do. The other type of person is those with an already existing skill set. If you are a licensed surveyor, you're bringing another tool in. If you're trained as a cinematographer or as a photographer, if you're in the ag field, you're an agronomist, and you're looking for another tool for your toolbox, they fit really well as that additional tool. Most businesses that I found that center just around UAS without having another skill set with it generally are fairly short-lived. So if you do want to go the small UAS route, absolutely start looking at a specialty. Whether it's ag or inspection, it'll definitely pay off in the long run. Get the classes that you need. Get into those different technologies that can really help your individual fields. For the people that those two types of people don't describe, there's some other options, and there's some other options that are really well set in place. They're reliable. You got a job every day, and that's when we start talking large UAS. When I say large UAS, there's really no defined terminology around, this makes a large versus a medium. Small is well defined at, under 55 pounds and less than 100 miles an hour. But when you get anything above that right now, it's really not defined. So when I say large UAS, I start talking about really those things that are in use today in the Army on the kind of tactical side. So when you look at your Shadows, when you look at the Bat-12s from Northrop Grumman, looking at some of the Yamaha products like Yamaha RMX, all these aircraft are 150 pounds plus. hours of flight time, and usually they're using some kind of combustion type engine, whether it's just a typical reciprocating engine or something like a radial engine. So that's kind of what I talk about. So once you get from that size and above, that's kind of what I consider large UAS. And the large UAS field is actually really hurting for mechanics and technicians these days. When you start looking at the type of people who go into these jobs, they or the type of training that they get. A lot of the folks working on the power plant side, they're trained as airframe and power plant folks. They go through and they actually get the certification from the FAA to be an airframe and power plant mechanic. The FAA does not define what is necessary for a unmanned aircraft mechanic, even on the large stuff. So a lot of the folks that are actually manufacturing or servicing this type of equipment, they look for AMPs. They also look for folks that are comfortable with electronics and computer systems. When you look at these aircraft, they while the mechanical part is important, you got to have a working motor in order to make this aircraft fly. You also got to have a reliable airframe. But on top of that is you've got to have someone who knows electronics, who can work with all the little boxes inside of the aircraft, and then just as importantly, work in the ground control station. Now, the ground control station, that's basically if we take the cockpit off the aircraft and put it on the ground or load it somewhere else. But the skill sets necessary to maintain those are very similar to some of the skill sets in the manned world. I'd say they're a little more refined and a little deeper knowledge level, but it's still the same basic skill set. So there's a couple different pathways. If you're in the military or you're transitioning from the military, you've got some advantages that maybe some other folks don't. One, obviously, you got your GI Bill, but plenty you may have had training in an area that's definitely needed in the UAS field. So if you worked in IT, you worked with any electronics, if you were an aircraft crew chief or an aircraft mechanic, you've definitely got an advantage. And on top of that, most folks from the military come with some type of clearance, whether it's secret or above. And if you're interested in working with folks like Northrop Grumman, General Atomics, Lockheed, Boeing on their unmanned systems programs, most of those programs require at least a secret clearance to be able to get in there and work on it. So if you don't have that training, though, if you're not already an airframe and power plant technician, you didn't do any IT or electronics work in the military, there's a couple of different pathways to go to be able to get that training. Now, once you do get some of this training, you're not limited just to unmanned aircraft, although, I like personally being on the cutting edge of technology. But there's many positions in the manned piloting or in the manned maintenance world as well that really benefit from these type of skills. I mean, obviously the AMP certificate, but when you look at aircraft these days, they're very heavily reliant on electronics. There's not so many pulleys, systems, and wires that have to be maintained in order to move flight surfaces. It's all done electronically, by sending pulses down through to circuit boards that then cause actuators to move. So having somebody that really understands the electronics and the way they talk to each other is really a big deal. Then we look at computer systems, and you've got the not only up in the cockpit do you have the multifunction displays, the glass cockpits, but even when you start looking at the in-flight entertainment, that's a huge field where knowing electronics and knowing computers can really give you a big advantage. But back to the unmanned systems side, so you can go out and there's plenty of colleges out there that will teach you all about the information you need in order to get your AMP. They'll also teach you all about computers and cybersecurity, networking, and then of course there's electronics and mechatronics programs out there that would really suit your needs. So Northland, we actually have all those, and we've got a large UAS maintenance training program that's not available anywhere else. So we're kind of a one of a kind like that. but we bring in students and we teach them the A and P stuff, the basics that they need in order to work on aircraft. But then we go in deeper and we start talking computer networking. We have them build a computer from scratch and be able to understand what each part does and identify it. When you start looking at the control station, the skill sets and requirements for those type of jobs are relatively similar to other IT jobs. Generally not as in depth, but the ability to understand how everything is talking to each other. Inside a control station, you've got multiple boxes in there, network routers and switches. Everything's connected via either LAN cable or an RF type cable, maybe even fiber optics. So understanding that hodgepodge of skills would really go a long way. So in the manned UAS world, if you look at manned versus unmanned, if you were trying to make that type of decision, the average manned aviation maintenance technician out in kind of the Midwest area or upper Midwest area, they're averaging right about 40K or so a year, straight out of school, no experience. When you start looking in the same area for unmanned systems, I've got students that again here in the upper Midwest, they come out of school and they're making 54, 55K a year with zero experience. There's definitely a chance for that to grow quite a bit if you're willing to do things like go on deployments and go back overseas, and not necessarily to places like Iraq or Afghanistan. I've got plenty of students who go out and they work in places like Guam, Sicily, Germany, UAE. There's plenty of options out there. There's worldwide, the UAS field is growing, especially the large UAS field and then the defense field. So if you're working in defense on UAS, there's a good chance that you can make a nice career for yourself out of that. You get to travel, or you can stay in one spot. Depends on all what you're looking for and what your particular employer is looking for. But there are quite a few options out there to fit most any lifestyle working in the large UAS field. Now, as we progress and as the safety agencies such as the Federal Aviation Administration, or if you're looking outside the country, ones like EASA or CASA. EASA is the European Aviation Safety Agency, and then CASA is the Canadian one. But they're really looking to integrate these large UAS into the airspace. It's not quite there yet, and it's probably going to be a little bit till it's actually there, because these organizations, their entire job focuses around safety and safety of flight within the National Airspace System. So it's going to take a little bit of time to really build it out to where it's all over the place. That being said, there are plenty of fields that are going to benefit really quickly once they start doing it, and they are providing exceptions, and they're doing testing at some of the national test sites regarding large UAS and different uses. But when it comes to the agriculture field, ag is a really big one that's really going to benefit for large UAS. That benefit comes in the fact that we can fly better, we can fly faster, we can carry more of a payload because we're not worried about a pilot or the safety systems involved when you do have a pilot. The safety systems are more for the aircraft itself and avoiding hitting anything. But they're able to then carry more fertilizer to spray, more nitrogen to spray, more pesticides. But then they're able to apply them in a more strategic way, in a way that actually uses less of the product, which means less overspray, less runoff, better for the environment, and then add to that in these agricultural places where we can use these. It's generally really rural. They're smaller populations, so it's less of a safety risk than, say, flying a large UAS over a populated city. So, but there's a lot of other industries as well. I mean, even when you look at, again, going back to manned aviation, a lot of the newer aircraft, they'll take off by themselves, they'll fly the route by themselves, as long as it's been programmed correctly, and then they can land by themselves as well. So we're not far off even in the manned world of unmanned systems. And they're getting closer and closer to more of the optionally piloted aircraft than the manned aircraft that we're used to seeing. So I don't think that it's really going to take that long to get them in, to get them out there and working. And once that happens, there's going to be another boom. And I say another boom with the jobs because even if you look right now in avionics specialties, the Boeing jobs report over the next 10 years specified that they needed something like 750,000 technicians over the next 10 years in the aviation world, particularly around avionics and the mechanical side of the house. So there's definitely a huge need for these positions to be filled. We rely on aircraft so much, again, whether it's manned or unmanned, that we can't afford to not produce folks to work in these fields. So if you are thinking about a career and you're thinking about a career with drones or with UAS, I'd challenge you to look into some of the larger UAS and some of the opportunities that are available with those. Working on things like I've got here over my shoulder, an Intercon Mini Falcon. It's about a 14 by 14 foot aircraft, and it can stay up for 12 plus hours depending on configuration. There's a lot of jobs that it could do that you won't be able to do with small UAS. When we look at things like firefighting out in the wilderness, like the fires in California or over in Australia. In fact, I believe over in Australia they recently lost one of the planes that were meant to carry water and dump it on the fire, along with everybody on board. And it's tragedies like that that can be avoided by using things like unmanned aircraft. And so, like I said, once the technology is proven, once the safety agencies get the case made to them, you're really looking at being first in the door for some of these fields. And there's no limit to the career that could come out of working with these systems. Thank you.